Alright, in this video we're going to kick off our first microservice by writing the domain layer. We're not going to go too nuts in terms of classes here, properties, methods, and domain events and integration events. We're just going to start real simple with one of the microservices that's going to make up our shopping application. And the first microservice we're going to focus on is the catalog service, where we're basically going to have a list of the different products that we offer. So a couple things I want to do here first, though, is in my solution here, I'm going to add a solution folder for libraries, and I'm going to move our shared libraries, we only have one so far, into the libraries solution folder. And I'm also going to create a solution folder for our services. So each of the microservices will be under here. And then what we're going to do is we're actually going to have a solution folder for each of the services that we're going to develop here. So the first one is, as we said, our catalog service. And then the consistent pattern I use under here is we're going to have typically three projects. One is going to be our entry point API layer. Then we're going to have an infrastructure layer, and we're going to have a domain layer. Again, that's following a clean architecture pattern. So if you're not familiar with clean architecture, highly recommend you look at it. But we're going to start with the domain. So whenever I'm writing a microservice, my recommendation would be always start with the domain layer and work out. So start from the domain, which is, again, thinking about it from the business perspective, which is really what domain-driven development is all about. So we're going to create a new class library here. So we're going to create a new project, new class library. And then this is going to go, I like the folder structure here on disk to match my solution folder structure. So we're going to have a services folder. And we are going to put a folder here for catalog service. And then under here, this is where we are going to put our catalog.domain. So name of the microservice followed by whether it's the domain layer, infrastructure layer, or API layer. So in this case, the domain layer, and we're going to go ahead and hit next, create. Get rid of our very first class that comes along for the ride. And then within the domain layer, there could be multiple areas of code. So typically, what I like to do here is name this in the plural fashion. Sorry, products. And here we're actually in the products folder. Right in the root of the products folder is where we're going to create our first actual aggregate root. So we're going to have a product class that represents our different products. And here's where we're going to inherit from our aggregate root. Class that we created in a previous video. Looks like it doesn't have the reference, so we're going to go ahead and add it here. We're going to right click and we're going to add a reference, project reference to our shared domain. And so the domain layers should inherit from the domain, shared domain, but that's it. So that in the clean architecture world, the domain is an independent library that doesn't inherit from anybody else. And the infrastructure will reference this library. The API will reference this library, but he himself doesn't reference anything other than our little shared library where we defined our aggregate roots and other entity classes. So first thing we want to do is establish the properties that are going to make up our product. So we can have a string to represent some sort of product code. And again, as we've talked about in prior videos, we're going to make our setters private so that people are going to be forced to, if they want to change the state, go through method calls, constructor calls, etc. So we're going to have a code, a name, we should have a description, and that'll be good enough for now. And so we're going to have a product constructor that calls our aggregate root constructor, where we have no ID. And then we're going to, and so that first constructor is primarily going to be used when we're pulling items out of the database. So when we're pulling an item out of the database, we're instantiating the object, setting its properties. We're going to take a look at, from an infrastructure point of view, that'll be part of the infrastructure. Where what I'm going to end up using here is a micro ORM for all of that, and it's just going to require a parameterless constructor. So we're not going to use the product constructor that doesn't pass any parameters when we're calling from other code. When we're calling from other code, what we do want is a constructor that looks like what IntelliSense is giving me here. So we're going to pass in our three properties here. And this would be the instantiation of a new product. And so we can rely on our base here that is actually going to end up assigning a GUID, right? So just to show you that traceability, the aggregate root inherits from entity, which comes all the way down, which means our ID is going to get assigned a GUID when this constructor gets called. So at this point, we're going to end up having our constructor. And then we're going to have a method by which they can update these values here. So very similar, just going to copy these guys. And so now we've got our first aggregate root. It's got a couple of properties that define the product. We've got a constructor by which someone can create one of these aggregate roots. We have a method by which they can update it. They can't individually come in and set properties, right? So they can't change the code of the product simply by setting a new value on that property. We want them to come through the update method in order to be able to do that. All right, so one other thing that we're going to be implementing is interfaces that the infrastructure layer is eventually going to implement around interfaces for the repositories that will allow us to retrieve these aggregate roots. You'll see that I also have mapper classes and DTOs. DTOs being used to ship data across the service layer boundaries back to the client. And mapping classes that take care of mapping business objects to DTOs and vice versa. So one of the when I was talking about what libraries we're going to have for each microservice, I mentioned that we're going to have a .domain, we're going to have a .infrastructure, and we're going to have a .api. You'll see in some clean architecture approaches that there's also a .application, and in the .application is where people would put the interfaces for the repositories, mapper classes, service classes. I used to do that, but I've since stopped doing that, and I like to put that actually in the domain layer because sometimes I do want to be able to pass the interface of a repository into a method of one of my classes here. So, there are cases where, I might have a method that might look something like this. I don't know, update pricing or something like that. And maybe he needs some sort of repository to, we can pretend there's some sort of accounting repository that has debit and credit accounts. So there might be an account repository. And I need to pass that in order for him to actually carry out the logic, because we don't want anemic business objects. We want business objects that know how to perform business actions, and sometimes to perform those business actions, I need a repository. So if the account repository were defined in a separate library, the application library, and in clean architecture, the domain library should not have any references to any of the other libraries, well, then I can't get a reference to that repository. So I'm sort of stuck. So that's the reason why I prefer to include the interfaces for the repository services and so forth in the actual domain layer for these situations where we do want to be able to pass in certain services or repositories to the business object methods that will allow it to carry out whatever operation it's attempting to perform. So with that in mind, we're going to have a folder in here for repositories. And we're also going to have a folder for DTOs. And we're also going to have a folder for mappers. there will sometimes be also sometimes depending on the domain and what domain we're working on, have a services folder as well. So we'll see it when it's necessary. But these three folders here are going to be there almost every single time. So under every single domain area, in this case products, this is my typical approach. Is right in the root of the folder we're going to have our domain objects, which will be our aggregate roots, our entities, our value objects. Then we're also going to have our DTOs folder, mappers folder, and repositories folder. So one of the things that we are going to have here is an I product repository, and this is going to be an interface. And so this will be the interface that represents the repository that will allow us to pull products in and out of the database and run queries against the persistence layer. So again, just to repeat from the domain-driven perspective, the only things that can be moved in and out of the persistence layer via the repositories are aggregate roots. So that's why our product is an aggregate root. It is something that we want to be able to transactionally pull out of the database. So he's going to have an I product repository. And then from a DTO perspective, we're going to have a product DTO. So why DTOs? So the business objects are really meant to be rich, non-anemic is really the term that often gets used. So we want them to be rich with functionality, business logic, and various methods, whereas the DTO is really meant to just be a data transfer object. So when we want to send a product back to the front end or the calling client, we want to be able to pass over through actual data payloads. So we don't want to be serializing the business object, we want to be serializing a DTO. So our product DTO is going to represent when we're taking a product, which is a business object, and looking to transfer that back to the caller. So whenever we're crossing that boundary of our internal domain world into, hey, here's a response object that we're sending back to a caller, we want to convert from our business objects to our DTOs. So typical thing I usually do is just start looking to copy and paste. We're going to come over here. We for now just want the same properties. Now the difference is here for the purposes of serialization, deleting too much there, and for using tools like IMapper to automatically map from business objects to our DTOs. And also because our DTOs are going to sometimes be coming in as actual payloads on the request objects, we need the public setters in this case. So our business objects, we do not want people and nobody's going to be handcrafting a DTO. We're going to be using libraries that automatically convert our business object into a DTO, and then the DTOs may come in as a payload on an actual request object. So when the client wants to send us data, we're going to receive that in the form of DTOs. So for the automatic mapping of when the object comes in on, say a .NET Core API, we need to have public setters to allow it to auto map our domain model, not our domain model, but the actual model coming from the client. So here it is perfectly fine to have the public setters, and we want to represent our product object. This also means that there are cases, the other reason for DTOs is there are cases when the response we want to send back to the client is not necessarily a direct representation of the business objects, where we might be combining a couple business objects into a response object. So we're going to be pulling properties from multiple business objects, or we might be sending back only a few properties from the business object, not the entire thing. So again, being able to have concrete classes that represent that transformation of I need to transform my business object into the actual thing I'm going to return to the client is where the DTOs come in. So for now, we've got our starter DTO here, which maps to and aligns with the properties that we have on our product. So we're done with our DTO class. And then we're going to have potentially mapper classes. And actually, you know what? I'm gonna delete this for now. Because there's a lot of cases where we're not going to need that. We're only going to need mapper classes if there's some sort of custom mapping that we want to do between our business object and our DTOs. A lot of times we're going to be able to just use IMapper, a library and framework available in C# that's going to do a lot of that for us, do the bulk of that in the majority of cases. So we've got this all done. The only thing we haven't done is really talk about, okay, we have this iProduct repository interface, but obviously there's nothing on it at the moment. So what we're going to cover in the next video, we're going to actually create some base classes and some base interfaces that are going to be related to the repository pieces. So we're going to start to navigate into that in the next video. And then once we've completed that, we're going to be able to come back and implement those interfaces here on our iRepository. So stay tuned for the next video. Time for a shameless plug for my personal LLC, Keystone Code. I've been doing software development for 20 plus years now, and I've been lucky enough that I've played a lot of the different roles that go into software development, from back-end developer, front-end developer, full-stack developer, team lead, head of engineering, chief technology officer, business analyst, and architect. So if your agency or company has any needs across those different areas, whether it be a need from just understanding what those roles are, or have a need to fill one of those roles, either from a training perspective, a mentor perspective, or an actual hands-on perspective, feel free to reach out. So I can be reached at my email address, dmichael@keystonecode.com, or on the website at keystonecode.com. Thanks.